Hey guys, so I wanted to go over the possible questions when it comes to inflation worksheet that I posted on Wednesday, I guess, of this week, and how we worked through those questions. So I have my copy right here. We're going to kind of do it together, and then if you have any questions, you can leave a message on this video or contact me through Schoology, Remind, whatever. So here's the questions. It's best if you just start reading from like the very top. So sometimes you have to calculate nominal and real GDP of a made-up economy selling 2 or 3 goods. That right there is a market basket. In reality, our market basket's like 8,000 goods, the CPI. But sometimes you're given a table like this where you have what you sold, how much you sold it for maybe for a couple of items, for over several years. For nominal GDP, you're just trying to figure out how much money was made that year. So in 2016, you sold 10 hamburgers at $1 each and 5 phones for $10 each. So you just do some multiplication and some addition to figure out that you made $60 in 2016. 2017, 2018, you're just going to do the same thing. I sold 20 phones at $1.50, 20 hamburgers at $1.50, 10 phones at $12. You're going to make, I already did the math on the, cheating, $150. And then if you do the same thing for 2018, you're going to get 510. Which seems like your economy really grew. It went from making $60 one year to $510 3 years after that. But here's the thing. Yes, you sold more every year, but prices went up. So how much of that is actual growth and how much of that is just inflation? So real GDP would be calculated as having one of these years. It doesn't matter which year. So we're going to take 2016 as an example to be the base year. What that means is you're going to use 2016 prices. And just we're going to pretend, well, what if prices stay the same? What if instead of prices going up every year, they stay the same? And you could have done this with any years. We're just using 2016 as our example. You use the base year prices, $1 for hamburgers, $10 for phones, and then figure out how much money is made each year using those prices. So we're going to be using the quantities of the year I'm talking about, but the prices of 2016. I could have done this with any year. I just chose 2016. So for 2016, real GDP, it's going to be the prices of 2016 and the quantities of 2016. So 10 hamburgers at $1 each, I made $10. And then I sold 5 phones at $10 each and made $50. Together, I made $60, which is exactly how much you made nominally and real, because 2016 is the base year. See how it says here? 2016 real and nominal should be the same value, since that is the year we use as our base year. So if I had picked any year, you would have gotten the same answer for that year. But for 2017 to 2018, our numbers are going to change. We're going to basically pretend that 2016 prices are the same all the way down. So for 2017, it's going to be 2017 quantities times this 2016 prices. So I sold 20 hamburgers at $1 each, 10 phones at $10 each, and that's going to give you $120. I'm cheating. You know, I'm going to move this so it's not super obvious when I cheat. And then on 2018, same thing. You're going to use 2018 quantities and multiply that by 2016 prices. So 30 hamburgers at $1 each plus 30 phones at $10 each gives you a grand total of $330. So you have real for every year and nominal for every year. This is if you don't have a CPI and you just have to use a table like this. Sometimes they're going to give you a CPI and then you're just going to be using this equation down here. But we figured it out without the CPI. In fact, that's the only thing we don't have. It says, let's use the information from question 1, which is all right here, to answer another possible question type. Sometimes you have to figure out the CPI of certain years if it's not given to you. So for each of these years, we have nominal GDP for 2016, 2017, and 2018, and real GDP of 2016, 2017, and 2018. We just solved that. Now we can kind of put it in this equation and solve for CPI for each of these years. So for 2016, remember it's real equals nominal divided by CPI times 100, and I'm solving for CPI. So real of 2016 is $60. Ooh, let's try that again. $60. Real is equal to nominal over CPI. Nominal for 2016 was also, there it is, $60. Times 100, but all that's over like CPI. Not all that, but just that's. So you can solve for CPI, and basically you're going to be getting, I mean, think about what it would have to be. 60 divided by something times 100 equals 60. That's got to be 100, so that can just cross off. So 60 equals 60. That and the CPI of the base year will always be 100 because there's no inflation from 2016 to 2016 because there's the same prices. So 2017, you will have a change here. The CPI of 2017, we're going to be using these numbers up here. So real GDP of 2017 was $120. And that's equal to nominal 2017, which is $150, over CPI, which is what we're solving for, times 100. If you solve for CPI, you will figure out that the answer for CPI should be 125. Now you do the same thing for 2018. 2018 real value was 330, equals nominal for that same year, 510, over CPI times 100. Solve for CPI, and you're going to get 154.5. All right, so now we have CPIs of three different years, and if you have different CPIs, you can figure out the inflation rate. So we're going to use the information from question 2, which is what we just did, to answer another possible question type. Sometimes you have to calculate the inflation rate between 2 years. It's a simple percent change formula using price indexes or CPIs from different years. So here's the equation. It's the equation, you had it written down a little bit differently in your notes, but it's the same thing. I think you probably had new CPI minus old CPI over old CPI times 100. This is the exact same thing. Price index of year 2, price index is the PI, CPI of year 2, minus price index of year 1 over price index of year 1. It's the same formula. Where you're just trying to figure out, you're taking these years, CPIs, are the old one, and this is the newer date. So we're trying to figure out percent change between these two CPIs. I had it written down right here, but I'm just going to rewrite it up here so I know them. In 2016, CPI was 100. 2017, CPI was 125. We figured that out on the front page. And 2018, the CPI is 154.5. So we're figuring out percent changes between a few of these numbers. So for the first question, you're doing percent change between 2016 and 2017. 2016 and 2017. So that's the old CPI, that's the new CPI. So remember, new CPI, 125, minus old CPI, 100, over old times 100. This one's pretty simple. You always like it when the first CPI is 100 because these are going to cancel out and then it's just subtraction. It's just 25. And this is figuring out inflation rate, which is in percent form. So it's 25%.
Teachers, at this time, you may dismiss the car riders and the drivers. If you're a driver or a car rider, you are dismissed at this time. Have a wonderful Wednesday evening. And bus riders, hang tight. We'll be dismissing you soon.
Okay, so The next one, you're doing this again, same formula, but this time with the 2017 acting as your old CPI and 2018 acting as your new CPI. So between these two numbers. So 2018 comes first because that's new. So it's the 154.5 minus the old CPI, which is 2017, 125, over old 125 times 100. So solve for that, and you're going to get, I'm cheating a little bit because I already did it earlier, 23.6%. And last one, we're going to skip over 2 years between 2016 and 2018, where 2016 is old, right here, and 2018 is the new one. So it's new minus old over old times 100. But since we're starting from 100, it's just going to be simple subtraction like it was here. So it's just going to be 154.5 minus 100, which is 54.5%. So this is basically, we just practice different skills throughout this entire thing of how to solve questions that are related to this. This is a sample FRQ that is basically everything we just did kind of wrapped up into one question. You have 3 products, food, clothes, and entertainment, over 2 years, 2009 and 2010. And how many you sold for the price for both years, how many you sold, and then there's the price. On number 3A, it says the outputs and prices of goods and services in country Y are shown above in the table. Assuming that 2009 is the base year, calculate each of the following. The very first thing, nominal GDP, we're just calculating how much money they made in 2010. It's not an equation or anything. It's just how much money did they make. Well, here's 2010. They sold 8 foods at $2.50, 10 clothes at $10 each, and 5 entertainments at $5. So you just multiply these and then add all of the sums. So this was $20 and $100 made here, and this is $25, for a total of $145 was made in 2010. On double I, it says the real GDP. Okay, how to solve for real? You need a base year, just like we did earlier. We used 2016 as the base year, and we took 2016 prices. Same thing here, but we're going to be using 2010 prices. Or actually, it says 2009 prices. So these prices right here. But the quantities of 2010. How I know quantities of 2010? Because we're solving for real for 2010, but prices are going to be fixed from 2009. So this time, you're just multiplying 8 times 250, 10 times 6, and 5 times 4 to get a grand total of $100. So yes, I made more money. Like, look, in 2010, I made $145. Yeah, but if prices had stayed the same from year to year, you really only would have made $100, not $145. The difference between those is inflation. On B, it says if 1 year the price index is 50 and the next year the price index is 55, what's the rate of inflation from 1 year to the next? So this is a percent change formula. It's right here. New CPI minus old CPI over old CPI times 100. So here's the old one, 50, because then the next year it's 55. So that must be the new one. So it's 55 minus 50 over 50 times 100. Because that's new minus old over old times 100. You solve for that, you're going to get 10%. On C, it says, assume that the next year's wage rate is 3% higher than this year's because of inflationary expectations. The actual inflation is 4%. At the beginning of the year, will your real wage be higher, lower, or same as today? Well, here's the thing. If you get paid 3% more, your nominal wage goes up 3%, inflation is going to eat away at whatever the nominal is. This is the Fisher equation. Nominal percent minus inflation equals real. So if your nominal paycheck goes up 3%, you get paid 3% more, but at the same time, inflation's going up 4%, your real wage is actually falling by 1%. Prices are going up at a higher rate than your nominal wage. So your real wage actually fell by 1%. So your real wage will be lower. You are worse off. That's not really a good raise at all. And then on D, this is a very similar type of question. It says that Sarah gets a fixed rate loan from a bank when the expected inflation rate is 3%. If the actual inflation rate turns out to be 4, who benefits from the unexpected inflation? Sarah, bank, neither, or both, and explain. It's never going to be neither or both. One's going to be hurt, one is going to be helped by unanticipated inflation. And here, I'm going to steal this. When the actual inflation is greater than expected inflation, remember, if you are having to pay money that has less purchasing power, because with inflation, your purchasing power goes down. Your purchasing power goes down. And so if you have to pay money with lower purchasing power, okay, that's no big deal. I don't mind paying money that's worthless, but if I'm being paid money that is worthless, that makes me sad. So pay money that's not worth anything, okay. But you're paying me money that's not worth anything, that's no good. So who's going to benefit? Sarah, the bank, neither, or both. Well, Sarah got a loan and now she has to pay it back. She has to pay the loan back. So she is going to be happy with this. The bank will be hurt, but she's paying money back that has lower purchasing power because inflation is higher than what was expected. And so she is going to benefit from that because what she has to pay back doesn't nearly have the purchasing power it used to. Hopefully that makes sense. Hopefully my hand wasn't shaking too fast. I'm holding this with my own hand.
Down to those buses. Thanks.
And if you have any questions, you need to be able to do these skills, but mainly if you did okay on this little FRQ on the back, then you're probably in a good position. So hopefully that makes sense, and message me if it doesn't, and we will cross that bridge when we get to it. But have a good day.